Hello, my name is Brandon Sirhan, and joined by Jonathan Castro, Nishan Nat, and Emma Moyer, we will be tolerancing two mating components of a Rapid E26 stapler, which we found the CAD for on GrabCAD, shown in the references. The two mating components for the stapler that we intend to tolerance are the bottom housing and the axle pin, as shown in this slide. Through application of GD&T, we intend to control the location and size of the pinhole on the bottom housing, as well as the size and the form of the axle pin. To control the location of the pinhole, we established three datum planes as shown by the GD&T symbology in the drawing on the left. Datum planes A, B, and C constrain the location of the bore in the X, Y, and Z coordinate axes. These datum planes can be imagined on the 3D part as shown in the figure on the right. In selecting the tolerances, two main factors were taken into consideration: the manufacturing process used to create the part and the scale of production. The most predominant manufacturing process used in creating stapler parts, specifically the metal housings that make up staplers, is metal stamping. This process is capable of achieving high repeatability and accuracy when piercing a hole within a tolerance of roughly plus or minus 0.05 millimeters. Due to the mass production that this product is likely scaled to, it can be assumed that the most staplers are intended to be manufactured with low-cost design standards. This also infers that there are looser tolerances for this product. Additionally, it is reasonable to favor a larger tolerance for the location, favoring accuracy of the location of the bore when you manufacture it over precision. To account for the capabilities of metal stamping and the cost of production, we tolerance the diameter to have a lower limit of 4 millimeters and an upper limit of 4.25 millimeters. This is justifiable for the location of the pinhole in the horizontal and vertical directions, as shown in the image here, with the horizontal positioning being anywhere between 103.67 millimeters and 104.17 millimeters from datum B, and the vertical positioning allowed to be anywhere between 4.922 and 4.422 millimeters. For the size of the pinhole, the tolerance value must take compression between the axle pin and the pinhole into consideration. As the stapler needs to be opened in order to load staples, the axle pin needs to act as the pivot point for this motion to be allowed. It must be met with little to no resistance. Therefore, a lack of compression between these parts is ideal. This was also our main concern when choosing tolerances for the axle pin. In order to control the form of the pin, we chose to use cylindricity. Cylindricity is a common GD&T control applied to pins and important cylindrical parts. It is especially important when functionality relies on roundness of the pin and straightness of the central axis of the pin. As these mating parts are likely manufactured with loose tolerances, it is necessary to ensure that the diameter of the pin will always be smaller than the diameter of the hole. To ensure this, the tolerances for the axle pin diameter was determined by taking into account the tolerances we chose on the bottom housing pinhole. By choosing the tolerance of the diameter of the axle pin to be 0.25 millimeters, specifying the lower limit to be 3.75 millimeters, and the upper limit to be 4 millimeters, we ensure that the pin can always mate with the pinhole. Following GD&T guidelines being that the maximum radial envelope, in this case the pin diameter tolerance boundaries, cannot exceed your maximum diameter tolerance. The cylindricity tolerance envelope of 0.125 millimeters was determined with respect to the tolerances of the diameter. This value represents the boundary limits used to determine if the form of the pin is acceptable so that it will be able to mate with its counterpart and ensure the assembly will have proper functionality. Here are the references our team used for this project, and thank you all for watching. Have a pleasant rest of your day.